Each year, Thayer School honors a member of the greater scientific community with a Robert Fletcher Award given in recognition of distinguished achievement and service in the highest tradition of the school. When Robert Fletcher was selected by our founder, Sylvanus Thayer, and Dartmouth President Asa Dodge Smith to become Thayer School's first professor and dean in 1870, he was a 23-year-old Army lieutenant serving as an assistant professor of mathematics at the U.S. Military Academy. Over the ensuing 65 years of service, Fletcher left a strong, lasting impression on generations of students. For students, his accomplishments as director and teacher merged with his quality as a human being. In addition to leading the engineering school, Fletcher designed and supervised construction of the steel bridges across the Connecticut and White Rivers and waterworks for the towns of Hanover and Enfield. Fletcher's many activities contributed to the prestige of Thayer School, the betterment of his community, and the advancement of engineering education. Today, we are honored to present the 2019 Robert Fletcher Award to France Córdova. France Córdova is an astrophysicist and the 14th director of the National Science Foundation, the government agency charged with advancing all fields of scientific discovery, technological innovation, and STEM education. Córdova is President Emerita of Purdue University and Chancellor Emerita of the University of California, Riverside, where she was a distinguished professor of physics and astronomy. She also served as Vice Chancellor for Research and a professor of physics at the University of California, Santa Barbara. Previously, Córdova served as NASA's chief scientist. Prior to joining NASA, she was on the faculty of Pennsylvania State University, where she headed the Department of Astronomy and Astrophysics and served as deputy group leader in the Earth and Space Sciences Division at the Los Alamos National Laboratory. She received her Bachelor of Arts degree from Stanford University and her doctorate in physics from the California Institute of Technology. Córdova's scientific contributions have been in the areas of observational and experimental astrophysics, multispectral research on X-ray and gamma-ray sources, and spaceborne instrumentation. She is a fellow of the American Association for the Advancement of Science and the Association for Women in Science. Tomorrow, she will also receive an honorary degree from Dartmouth. Please join me in welcoming Dr. Córdova.
Good morning. Thank you, Dean Ray, for that generous welcome, and a special thanks to you, Provost Helbely, President Hanlon, and the Thayer School, the faculty of the Thayer School, for the Robert Fletcher Award. I'm honored to join the company of past awardees, many of whom are colleagues and friends. Well, congratulations, graduates. This is your day. You did it. You're receiving a degree from an extraordinary university and, what's more, from a unique college of engineering. The emphasis on an interdisciplinary curriculum, which integrates engineering and the liberal arts, the focus on innovation and entrepreneurship at the graduate level, and the stunning achievement of gender parity at the undergraduate level make this school a model for engineering schools everywhere. And congratulations to parents, family members, and friends. I feel your pride. I've sat in your seats as a graduate, as a parent, and as a friend, and even as a child when I and my 11 siblings watched our mother get her undergraduate degree at the age of 40. I've been invited to share with you some lessons I've learned along my own path, and to set the context, a little about my background. My engineering experience was building rocket and satellite payloads for astronomical observations while I was a graduate student at Caltech, and later when I was on the faculty of the physics department at the University of California, Santa Barbara. One such experiment was launched on a large satellite called XMM Newton from French Guiana in 1999. I was fortunate to witness the launch in person with my spouse and our 2 little children, and the experiment is still returning great data 20 years later. So engineering really works. XMM Newton was a European Space Agency cornerstone mission, and I was the co-PI on a telescope called the UV Optical Monitor. I was in charge of the digital processing unit that was the brains of the experiment. I've always recognized that observational astronomers need to be also engineers, as so many things can go wrong when doing observations at a telescope. I've been on mountaintops all over the world, and when things went wrong, we headed to the machine shop to fix them. The same is true for rocket launches, where it's crucial to know every aspect of your payload and how it integrates into the rocket electronics. Resourcefulness, I've learned, is one of the many traits developed in being an engineer. This was reinforced later when I was chief scientist of NASA. The first mission on my watch was the repair of the Hubble Space Telescope. And mind you, it was already ready to go when I got there, but I got to enjoy the experience. As some of you may remember, it was unknowingly launched with fuzzy vision, which distorted the images it took of the universe. It took imaginative engineers, computer scientists, and astrophysicists working together to come up with the perfect solution to restore Hubble's sight and make it NASA's most well-known, beloved mission. Throughout my life and career, I've worn many hats. My path to this podium hasn't been linear. It was shaped by opportunity and the choices that I've made. Once, when my thesis advisor wanted to recommend me to be a shuttle astronaut mission specialist, a friend said, "You're too old for that." I was all of 30 at the time. Never mind that many of the astronauts we know are over 50. Boardrooms and mission control centers, and yes, even space stations, are filled with people of different ages, backgrounds, and skill sets. About a year later, I set a personal goal to run the Boston Marathon. Another friend cautioned me against it, saying I was too inexperienced. But in this time, I ran it anyway. My story was even featured in a Toronto newspaper because I happened to run alongside a reporter who found it interesting that someone with so little running experience would jump into a demanding race. Well, I didn't finish in the top bracket, of course, but I did finish, and I have a certificate from the Slow Runners Association to prove it. Not to my naysayers, but to myself, only because I knew when not to listen. I'm glad there were no naysayers around when I chose to pursue a PhD in physics. I had just completed my bachelor's degree in English, and I was well on my way, as you can imagine, to another career. At the time, English seemed as far away from studying the universe as the stars themselves, but I was full of hope. You see, as a young girl, I was discouraged from going into science by teachers and family. Negative comments as I was starting a new path in physics would have brought back all that doubt, so I hid from the potential naysayers, and I stayed focused on my goal of becoming a scientist. And today, I'm thrilled that I followed my passion, even though I started late. It's led to a variety of deeply gratifying roles, from being a professor, an administrator in academia, and researcher at a national lab, to serving on the boards of corporate and nonprofit entities and working for the federal government at 3 science agencies. Had I listened only to other voices and not my own, I might have missed out on, well, everything in my life. And to this day, the night sky that entranced me as a child and enticed me again as a young English graduate is still my home and a constant source of wonder. Independent thinkers are anything but predictable, and grooming them, as many of your parents and professors will tell you, is far from an exact science. It often means traveling an uncertain path. Perhaps you too have taken a sudden turn and found the result to be a new and different life or personal growth. I can tell you from my own journey that in the moment, many of those turns felt like stumbles, but they can turn out to be shortcuts to your own unique destination. So what does this all mean to a room full of doers? Perhaps the best assurance I can offer today is that the training you've had here at Dartmouth is something you'll carry with you into whatever career you might choose. I've carried my undergraduate degree in English with me as I've pursued a career in science and administration. It's made me a better, clearer thinker and writer. It's made me appreciate the life of ideas and the power of articulating them. Everything you've learned here at Dartmouth is something important in your toolbox, something you'll draw upon later and reinforce the uniqueness of your contributions. And you know what? With that toolbox, you are ready for anything. What a background you have. My life experience has taught me that fundamental research in engineering is vital to addressing many of our most critical challenges, from smart manufacturing to resilient infrastructure to sustainable energy systems. Engineers anchor lofty ideas and turn them into concrete solutions. Perhaps the timeliest message I can leave you with is this reminder of the opportunity and responsibility you now bear, because our lovely, fragile planet and the very real people it serves need you now more than ever. We need your optimism and your enthusiasm. We need new voices representing every background. We need your willingness to think outside of the traditional boxes and to form new and unconventional partnerships. We need rebels who know how to listen and then follow their own inner voice. Rebels like the engineers of the Event Horizon Telescope, who are unfazed by the technical challenge of imaging a never-before-seen black hole. Rebels who, in an unprecedented feat that coupled imaginative science and engineering, linked together 8 ground-based telescopes around the world to create an Earth-sized telescope to do the job. And just a week ago, the Chief Information Officer for the United States told me that that image was the most downloaded image in history. It was a lot of rebels who had an idea, very little funding, but made use of major assets, made use of their brains and their imagination to do the job. We need rebels like Ray Weiss, leading a global team of both scientists and engineers who improved over decades, 4 decades, the laser interferometric technique that led to the discovery of gravitational waves on Earth. All of us were lucky to be alive at that moment a couple of years ago. Or rebels like your very own Dean Ray and the engineers at Cool Robots at Dartmouth, who are developing new models and control techniques for robots moving through snow or sand. Her research team and robots have supported glaciologists by surveying hundreds of kilometers of crevasse-laden ice sheets, aided volcanologists in mapping the ice caves at the base of Mount Erebus in Antarctica, and helped scientists study the grain structure of snow in the Arctic. And last night I had the privilege of meeting many of the faculty of the Thayer School who have dedicated themselves to listening to Arctic changes. We need rebels because maintaining the status quo won't cut it for the challenges of your generation or the generations to come. I know as engineers, you're all about improving on design, and the innovative curriculum and outreach here at Dartmouth have put you at the forefront of a true cultural shift in science. Today, the emphasis is on convergence, bringing together researchers from different disciplines to solve pressing challenges. This concept has changed the way we fund at the National Science Foundation. We actively invite researchers to think outside their disciplinary boxes about how they can approach solutions to grand challenges by widening their circle of computational, laboratory, theoretical, and experimental partners. As graduates of Thayer, you're already trained to think outside the box and well poised to practice convergence. Trusting in that training is your first step, and the next is to trust your intuition. That inner voice will be your guide along the many twists ahead, helping you to decide which counsel is right or wrong for you. Looking back, it's the advice that I've not taken that has shaped the course of my life. That same independence of thought has inspired our most recent breakthroughs in science and engineering. So class of 2019, I invite you to listen thoughtfully to everyone, but especially listen to yourself. There's only one person who can engineer your future. You are closing an extraordinary chapter of your lives. You're ready for the next. Congratulations, graduates.